And I guess I should share my screen. All right, can you all see the PowerPoint presentation?
Yes.
Yes, you're good.
Excellent. Let's see if I can actually do it in presentation mode. All right, so we are going to do an introduction to FHIR with the cute little FHIR logo. So if you ever see that on things, you know people are talking about FHIR. So we thought we'd actually start one level above. Just we weren't quite sure what people knew about interoperability in general. So we thought we'd start with the question of who is HL7? So HL7 is Health Level 7 International. It's a not-for-profit standards development organization. And HL7 works solely within the healthcare realm. And so they want to provide a comprehensive framework and related standards for the exchange, integration, sharing, and retrieval of electronic health information that supports clinical practice and the management, delivery, and evaluation of healthcare services. So a couple of key things there. It's all about moving healthcare data from point to point, but it's not just clinical stuff. It does include administrative, billing, a wide variety of different data types. And HL7 is not the only one working in this space. There are other standards development organizations that you may have heard about. IHE, ANSI, PDP, DICOM standard. All of those are within the healthcare space, but HL7 is really the big player in terms of healthcare interoperability. And HL7 has 1,600 odd members from 50 countries, so it is truly an international organization, which you can imagine in the last 3 or 4 months has been wreaking havoc with trying to schedule phone calls and virtual meetings, because they include folks from around the world. And it includes a variety of different stakeholders, including providers, government, payers, pharmaceuticals, EHR, vendors, consultants, a whole wide range of folks. And you'll see sprinkled throughout the presentation are going to be a number of links that you can always click on at your leisure and learn a little bit more. So HL7 is actually subdivided into different work groups which focus on particular areas. So a couple of examples are patient administration, who are more interested in the scheduling and registration side of things, pharmacy, and for our purposes, public health is an important one because that's where a lot of this work is going to happen. So the public health work group consists of a set of co-chairs from a wide variety of different backgrounds. Aaron Holt-Coyne from the state of Tennessee, Danny Wise, who works with Allscripts, an EHR vendor, Laura Rapley, who's on this call, and myself, both from Altarum. We're both co-chairs, and we will have a fifth one soon. We're just undergoing an election now. But in addition to those co-chairs, the work group is made up of members doing actual work in the office in the field. So a lot of people that actually work for state departments of public health, vendors are represented within the work group. So a pretty good range of folks. And again, the link here to a Confluence page, just where a lot of the work that goes on in public health is documented. What's actually important is that anyone can participate in the work group. You don't actually have to be an HL7 member to join the calls or get on the listserv. You do have to register an account, but it doesn't have to be associated with a membership or anything. So anyone who's interested in learning what the work group does or participating is welcome to. And there's some information on how to do that on that Confluence page. But really, what this primary thing that this work group does is this is where the project teams that are developing standards come to propose specific projects to create these interoperability specifications. And then the work group works with that team to develop them, ballot them, get them published, and then to handle the feedback that comes as people start to use and implement these specifications. The work group also does occasionally some educational presentations, that sort of thing too. So it's kind of a good mix of shop talk and sort of big picture kind of stuff. So the public health work group oversees work in a variety of different subject areas. We won't go through the whole list, but some of the important ones probably for this group are there's been a lot of projects in the last few years on vital records reporting, birth reporting, death reporting, right? And we've talked a little bit about how much birth defect reporting overlaps with birth certification. And so there's some synergy there. In general, just sort of provider reporting to public health, be it cancer or electronic case reports, reportable lab results. And then there's been projects for things like gathering occupational data for health. We know that, what people work at influences their health and that of their families. And then things like service referrals out to the community and that sort of thing. So a pretty broad range of subject areas are within the work group. So that's HL7 at sort of a high level. I will pause there, see if there's any sort of general questions about HL7 and how that works before we move into FHIR and the standard itself. All right. If not, we wanted to put FHIR sort of in a context with maybe some other standards that you've heard of from either work that you've done in the past or colleagues in your public health departments that are doing some electronic exchange. The original HL7 standard was version 2. No one seems to know what version 1 was, but version 2 is a really widely implemented messaging standard that's really forms the basis of much of the healthcare data exchange today, particularly within organizations. And so this is typically based on the idea that a system will push data out in the form of a message when an event happens. So a patient is admitted into the hospital, that registration system may push a notification of that admission out to the hospital's lab system so that it knows about the patient in advance of receiving orders for the patient, or maybe it gets pushed out to a billing system because they need to know what patients are in the hospital, or an order is placed, or for public health, an immunization is given. That can trigger a message from the EHR to the appropriate jurisdictional immunization registry that wants to know about all vaccinations that are given. So V2 is widely implemented. It's been around for, I don't even want to do the math, 33 odd years, I guess. It forms really the backbone of a lot of the exchange out there. More recently, version 3 and sort of an offshoot of that called CDA, Clinical Document Architecture, was developed. And this is really an XML-based system that is primarily used for exchanging documents, right? So their documents tend to be a little broader than the messages in V2, and they have additional concepts around them like signing and authentication. They're really meant to be a document rather than just a notification that something happened. And CDA is really the gold standard for exchanging clinical documents in the US. If you're at all familiar with the Meaningful Use or Promoting Interoperability program from the last 10 years, a lot of that is about exchanging patient information upon transitions of care using these CDA-based documents. And then FHIR is really the newest standard, and that's not even quite 10 years old. And FHIR really has aimed to take the best of V2 and CDA and incorporate it into a newer standard that can do a lot of different things. It can send documents, it can do messaging, it can do a lot more than that even. And we're going to spend the rest of our time looking at FHIR itself. So FHIR is kind of an odd acronym. It gives you a nice little pretty logo, but what does it mean? Well, it's about fast healthcare interoperability resources. So that's where FHIR comes from. And this was really developed to focus on the implementation needs of the community. For V2 and CDA, sometimes they weren't so easy to implement. And part of that just has to do with legacy of how systems developed support for it, particularly for version 2, but it also has to do with a bit on the standard itself. We're not going to go into that very much, but just be aware that FHIR, as it was being developed, there was at the forefront of people's thinking of keeping it easier to implement, right? Meeting the needs of the implementation community. There's a couple of links here that can give you some more information. In particular, the overview for clinicians might be a good place to start. It tends not to be as technical as some of the other documentation is, and so that may be useful for you if you want to learn a little bit more about it. I would recommend that link. So a couple of things about being implementer friendly. So what exactly does that mean? Well, one thing is that it's based on mature internet connection or conventions, right? You may or may not be familiar with things like APIs and XML and OAuth, but these are things that are used across a lot of different industries. They're not healthcare specific. And so what that means is it makes the technical implementation of FHIR a lot more accessible to a lot more people. You don't have to be a healthcare expert in order to do work with FHIR. And it also allows a broader range of tools to be available to developers and implementers to support the implementation. You don't have to create tools that are specific to healthcare because a lot of these concepts transcend healthcare. And in theory, and it's a bit of a theory, at least in my mind anyway, it really eliminates the need to know how each system exchanges data. In theory, getting data from an Epic system should not be that different from getting it from a Cerner or from an Allscripts. And similarly, sending data or interacting with departments of health in Tennessee and Alabama and Arizona really shouldn't be that different. Now, of course, that depends a little on how people interpret the spec and how it gets implemented, but the idea is that it should allow us to be a lot more similar across different organizations and different products. FHIR also has a readability component, right? Discrete data is always important for dealing with data. You have to have coded birth defects. You have to have coded genders for the patients. But it's also important to remember that humans have to ingest this information as well. And so FHIR does allow for a human readable summary of a lot of the data that's getting exchanged. And then one thing we'll just mention here, if you get into FHIR, you'll hear a lot about release 4, right? So this is, not surprisingly, the 4th release of the FHIR standard. It's the most current version, and it's the first to contain what they call normative data or normative content. And all that means is that some of the parts of FHIR have been so well tested and implemented enough that the community is confident that they've got things right. And so they've labeled some of the content as normative, which means it's not going to change much over time. There's not going to be major changes to it. There's not going to be breaking changes, things that aren't backwards compatible with what's been done in the past. And so being on release 4 can give developers and implementers a lot more confidence that what they build today will be usable going forward. And so that's an important thing because it makes implementation more likely. People are more likely to buy into supporting some of these FHIR standards once the content is normative. So what can you use FHIR for? The answer is really a lot of different things and in a lot of different contexts. But regardless of what you're trying to exchange, what type of data, and what context you're exchanging data between, the idea is the same infrastructure is used, right? So it doesn't matter if you're talking about a mobile app on your phone trying to access your history of blood pressure measurements to help you control your blood pressure, or it doesn't matter if it's a public health agency sending or receiving data from submitters, or a laboratory trying to receive orders and provide results back to the doctor and to the patient and to public health. regardless of what that exchange is, the same infrastructure, the same building blocks are being used. And so whether it's querying for data, exchange of documents, or pushing messages around, or providing services like clinical decision support, right? It all uses the same basic FHIR building blocks to do whatever it's trying to do. I'm not going to get into the technical bits of the way FHIR is used. If you are interested in the more technical side, there's some links here. But similar to what we talked about the last time we got together, basically FHIR can be used to either push or pull data. So pushing data is basically where a system knows something and it pushes data out to a partner system. It informs them of what it knows. And that's usually in response to some triggering event within that system. A provider enters an order, and then that order information is pushed out to a lab system, or they enter a vaccination, and that information is pushed out to an immunization registry. That should sound familiar. We talked about that a lot last month, about this idea of a doctor entering a birth defect diagnosis on the patient's record, and that EHR gathering up the data and pushing data out to the public health birth defect program. Alternatively, and this is a big thing in a lot of the world, is systems can also pull data using standard APIs. And so this is a much more direct interaction. So when a system like your application on your cell phone that wants to help you control your blood pressure, it can reach out to your doctor's system with the appropriate security and authentication and all that important stuff. But it can reach out and it can pull data out of that system for use in the application. And that's something that's really important, something that's not really well supported by V2 or CDA, that ability to ask for data and to receive it. It can be done in those standards, but it's not quite as easy. And similarly, these same APIs can be used not only for reading data, but for putting data, right? You can use these APIs to put data onto a FHIR server, although that's not quite as well supported in the community yet. A lot of what FHIR is about in the community today is about reading data when you want to read it. Pause there for a second before we get into sort of the next level of detail. Any questions about FHIR, or sort of at a high level how it's intended to work? All right.
What did API mean again?
Pardon me?
Sorry, what did API mean?
API? Was that it?
Yeah.
Yeah, an application programmer interface. So it's just a fancy way of providing specifications for how to do something. So these are in use all over the world. It's actually how a site like Travelocity can compare flights and prices among Delta and American and United, because Delta, for example, will provide an API, a set of specifications on how to query for data in their system that Travelocity can then implement. And so it knows how to ask Delta if there's any flights to Chicago next Tuesday. So Travelocity doesn't have to care how Delta stores that information, what their actual database or system looks like. All it is it's basically a front door into that system. And United provides one, and American Airlines provides one. So those three airlines can do radically different things within their own systems, but they provide a window into their system, a way to ask for data. Does that help?
Thank you.
Okay, and APIs form the basis of pretty much everything that's useful on the web, right? Amazon is based on APIs into systems, and so again, it's another one of these common concepts that transcends healthcare. All right, So we're going to talk a little bit more about how FHIR is actually defined and built. And the first thing we have to talk about are FHIR resources. So basically, you can think of FHIR as a bunch of Lego blocks. And basically what a resource is it's a template that describes the data elements or the attributes about a particular thing. So for example, the patient resource defines the typical attributes of a real person that's being seen as a patient. And we'll see an example of this in a minute, but you think that what does a person have? Well, a person typically has a name. They have a date of birth, they have a gender, they have an address. So what the patient resource does is it defines those attributes and a whole bunch more and lays down the rules about how to exchange that, right? A name is going to be free text, right? Because there isn't a set of names that all humans have. It can be pretty much anything, as we've seen famous people name their children really wonky things sometimes, right? But things like the gender, right, probably falls into a set category of options. Now, it's really hard to settle on what those options may be in some cases, but there's a discrete list you can come up with. Whereas a date of birth really needs to be a valid date, right? It can't be a string. It can't be, February 31st, right? There's rules around it. So what the patient resource is, it defines what the common traits of a patient are and how to send and exchange that data. And then there's resources for other things like an order or an immunization or a problem list entry that define what the common attributes of those different things are. And then you can put those things together. So if you're talking about, a birth defect report like we've been talking about, you need not only to use the patient resource, but you also need to use the problem list resource. It's actually called a condition resource, if I ever mention that. So you will need to put those two things together. You'll probably need to use the related person resource, which describes the next of kin for a patient. And then you can put all of these different blocks together to build out whatever you need FHIR to do for your own workflow. So a couple of things. So a resource unfortunately gets used for a couple of different things within FHIR. It's one of the more frustrating things that I found. FHIR people will talk about resources in the mode of that template, right? The patient resource defines how to describe a patient. But then they also reuse the word resource to describe an instance of that patient. So you can take that patient resource template and you can use it to describe a particular patient. So you could describe a patient named Craig Newman with an address in Madison, Wisconsin, where I live, and with my birth date, and with all of these other attributes that belong to me, and create a resource record that describes me individually, the patient. So you can really think of resources kind of as paper forms reflecting the different types of information. So if you can think about a paper form that you maybe fill out upon seeing the doctor the first time that includes, what is your name, what is your address, what is your phone number, right? That's basically what a resource is. Is it sort of a generic form or template for collecting information? So you can collect information on someone's allergies with one type of form and their current prescriptions with a different type of form. And that's sort of what a resource is. And then you can bundle these resources to create a useful clinical record. So my clinical record in FHIR form would consist of a patient resource that describes me, but then it may also contain a number of different allergy resources to describe my allergies to, cats and amoxicillin and, whatever else I'm allergic to. And then also condition resources for all of my problems. So, ear hair and, whatever else problems I have. This is just a small snippet of the total list of resources that FHIR deals with. So what this should be able to do is give you an idea of the sorts of data that can be exchanged with FHIR. So some of the resources deal with individuals. So there is a patient resource, and then a practitioner resource, which represents the records about doctors, people, nurses, physical therapists that play a role in providing healthcare. We mentioned related person as being the way to describe next of kin for a patient. There are entity sort of resources, things that describe organizations, hospitals, clinics, departments, that sort of thing. And then you can get into the clinical data, which is a lot of the stuff on the bottom. You can describe allergies that people have, adverse events that occurred, conditions or problems that patients have, procedures that have been performed on them. So this is really just a very small snippet of the list, but it should give you a relatively good idea of the sorts of information and the breadth of information that FHIR can actually handle. All right, so this is just a piece of that patient resource that I mentioned, just to give you an idea of the sorts of things that FHIR defines. So for a patient, what FHIR says is that patients have identifiers. This could be a social security number, it could be a medical record number, it could be a Medicare or Medicaid number, but everyone has at least, or should have, identifiers associated with them. Right, I'm going to skip some of these because some of them are a little deeper in the weeds. Right, everyone has the concept of a name and a phone number, a gender, a date of birth. Some people are deceased, and so it may be important to collect information on whether or not they're actually deceased or not, a yes/no answer to that question. And if they're deceased, a way to collect the time they died, and so on and so forth. And then, like I mentioned earlier, right, not only does it define that everyone has a name, but it tells you how to collect that name. It also says, how to collect, that you should be collecting the date of birth as a date and not as just a text string or something like that. And then it also actually, this column called card, or it stands for cardinality. This gives people an idea of whether or not a single person can have multiple instances of the element. So everybody has one date of birth, right? So the way that you read these numbers are sort of a minimum and a maximum. So the date of birth has a minimum of 0 and a maximum of 1. And that may raise some flags in your head going, but everyone has a date of birth. But the idea is that while everyone has a date of birth, you may not always know what that date of birth is. John Doe comes into an emergency room, is unconscious with no ID. Yes, that person has a date of birth. They have a name, right? But you don't necessarily know what it is at the time that you need to exchange data. So one of the things you'll see about FHIR is that it's fairly loose. It gives you the ability to document and exchange the date of birth, but it doesn't require you to always have that information, if that makes sense. And then some things like a name, you'll see are 0 to star, and that star is just a placeholder for more than multiple potentially. So you may have your legal name. If you got married and you changed your name, you may have a maiden name or a premarital name. You may have an alias. You may have a nickname. You can have all sorts of different names. And so the FHIR standard allows you, for a single patient, to define multiple names for them because they may be known different ways to different people and in different contexts. So as I mentioned, basically these resources are relatively open-ended. You can see from the previous one, not a whole lot is actually required here. Actually, in this little snippet, there is not a single one of these attributes which is actually required by FHIR to always be known and to always be exchanged. And that's on purpose, right? Because there may be use cases where you don't know the name. There may be cases where you want to exchange de-identified data and maybe you know the patient's name, but you don't want to send it, right? Because it's supposed to be de-identified. So the base specificity or the base specification is relatively open-ended. It doesn't actually put a whole lot of requirements on a system that wants to exchange data. And that probably raises a little bit of a red flag in your mind too, potentially, about if there are so few rules, how does anyone know how to exchange data? And that it's a good question. And the answer to that is that FHIR has defined a way to do what they call profiling. And all that is a fancy way of saying you're going to add additional rules to the basic rules that FHIR provides. It gives you a way to add additional rules to match what you need to do for your own system in your own workflow. So it gives you a way to say, when I want to exchange data with an immunization registry, for example, using FHIR, I need to send that immunization registry patient data. But for an immunization registry, when you're talking about a person, it's really important to know the date of birth, because a lot of what you do with immunizations is about validating whether patients are getting the right shots at the right time of life. And so it's critical to know the date of birth for the patient. So if you were looking to support an immunization workflow, right, you could take this patient resource, profile it, or add additional rules to it that says, even though in the base standard you don't have to have a date of birth, when you're doing immunization workflows, you absolutely have to have it. And so you can constrain this or add a rule that says the cardinality changes from 0 to 1. It can either be there or once or not there at all. And I'm going to change this to be 1 to 1, which means it has to be there. And so that's how you can actually use FHIR to fulfill very specific purposes, be it immunization reporting or birth defect reporting or COVID lab test reporting, is you profile these things. And we're not going to get into profiling at all today. I just want you to know that even though you may hear that FHIR is relatively wide open, there are specific ways where you can craft it to your specific needs so that you can ensure that you get the data you need or that you know what data to send to a trading partner. Similarly, some types of resources can be used in a lot of different ways, right? The poster child for this is a resource called observation. And an observation can really be pretty much anything that you want it to be. It's the way that you send laboratory test results. So what was your cholesterol value? Well, you send that as an observation. Blood pressure, you send that as an observation. The plurality of a pregnancy, that's one of the things that we've talked about. Well, that's just an observation about the mother's pregnancy. And so another thing that profiling is used for is to take a relatively generic concept like an observation and say, when you're reporting birth defect data, you should have an observation about the plurality of the pregnancy, and here's how you send that information. All right, so you've also heard me throw around the word implementation guide. We're trying to make a FHIR implementation guide, and all that is is that an implementation guide is basically a document that describes the workflows. So our implementation guide will describe what it means to report birth defects to a public health program, and then creating those profiles or those constraints that are then used to meet that workflow. So an implementation guide should set the context for the data that you're trying to exchange, when to do it, why you're doing it, and then describe the rules for actually doing it. And so we don't have I can't show you the birth defect implementation guide today because it's still very much under development, right? But there are a lot of implementation guides out there that you can take a look at. And one of them is called the US Core, right? And don't really worry about what it means. You may have heard about new rules that have come out that are requiring healthcare organizations and EHR vendors to provide these FHIR APIs so that systems can access their data. And the US Core Implementation Guide is simply a document that HL7 has put together to provide guidance on how to do that. And so one of the things that this US Core profile does is that it takes that patient profile that's in the base resource that is pretty wide open. It says people can have identifiers, but doesn't say they have to. It says that they can have a name, but doesn't require that you exchange a name. And it constrains those down. So if you take a look at identifier on the left hand, which is the base resource, which is open-ended, you don't have to have one, right? The US Core profile says, yes, you do. When you're meeting this use case as an EHR provider or a healthcare organization to provide patient data to the patient, right? You have to at least provide one identifier. Now, it still doesn't say whether that should be a medical record number or a social security number or, you know, just a chart number. Doesn't get to that level, but it says you at least have to have some sort of identifier and you have to have some sort of name associated with the patient, that sort of thing. So US Core has taken a relatively broad set of requirements and really tightened them down to say you have to have a name. Does that make sense?
Yes.
Okay. And then one other thing that it does is, this is an important piece. I didn't mention before, but FHIR is really built off of what they call an 80-20 rule. And what that really means is that when they're building this, this base patient resource, they only include things that are probably used in about 80% of the use cases. So you can imagine that name hits that threshold. Pretty much any use case you can think of probably involves exchanging the patient name and their gender. So those are included. But more rare things aren't actually included if they aren't used most of the time in most workflows. But what FHIR does is it allows you a way to extend the base standard and include ways of sending additional data. So one of the things that's really important for the US regulations, right, is exchanging race and ethnicity. Now that's pretty rare in Europe, right? Actually, in a lot of places in Europe, they're prohibited from collecting race and ethnicity information. So it couldn't go into the core, the base FHIR resource, but we needed it for US purposes. So this US core implementation guide, right, defined ways of sending race and ethnicity, and in this case also a birth sex. So it took the base resources and added stuff onto it. It bolted onto the side of it ways to send race and ethnicity. And that's perfectly fine, right? That's allowed by the standard. So not only, you know, does it define the basics of it, but it also gives you a way to extend it, to add new stuff onto it. All right, so there's already been a fair amount of work done on public health FHIR implementation guides. And our ultimate goal for our project is to create a FHIR implementation guide for birth defect reporting. And as we sort of mentioned before, what it will do is it will describe the workflow of reporting birth defects, and then describe the rules for exchanging the data that form the core of that birth defect report that goes from a provider to a jurisdictional program. And what that will allow is it allows vendors on both sides, both the EHR side and the program side, so the vendors for the systems that you're working with, it gives them a roadmap to implement the standard to help automate reporting. And that's a lot of what we talked about last week, where we talked about how a provider working in the EHR system, as they document a birth defect, that can act as a trigger for the EHR in an automated fashion to collect all of the information that forms a birth defect report, package it up, and push it to the jurisdictional program system so that it can be then processed and integrated into your systems. And again, right, that takes work, right? Both vendors on both sides have to do programming and have to be able to support it. But at least if we have a FHIR implementation guide, it tells them how to do it. It gives them a roadmap for doing that. So what public health programs are using FHIR today? Well, there's a couple of ways you can find out. One is you can hang on to this call for about 2 minutes and I'll give you an idea of what's been done out there. But if you're more interested in where FHIR is being used, there's actually a registry of these implementation guides. So again, you can click on this link. It will take you to an HL7 site, and you can search their list of published implementation guides to find what's out there. So if you are curious as to whether there is an implementation guide for electronic case reporting, you can go to that registry, type in electronic case reporting, and if there is an implementation guide out there for that particular workflow, it'll pop up and it'll give you a link to it. Now, spoiler, there is a FHIR implementation guide for electronic case reporting out there today. And so that's one of the ones you can find on this registry. Very shortly, we will be publishing actually a vital records death reporting implementation guide. That's probably, hopefully, it's just a couple of weeks away from being published officially. There's another implementation guide about bidirectional services referrals. This is all about exchanging referral orders between programmers or providers and community programs like tobacco cessation programs, and getting the outcome of these community programs back in the hands of providers, so that if a provider refers a patient to smoking cessation program at the local YMCA, there's a way to electronically refer that patient, and then that community program has a way of informing the provider of what the outcome of that intervention was. So that's an important one as more and more services are delivered in the community. So that's an idea of some of the stuff going on in the public health domain in terms of FHIR implementation guides. So where are we looking to go, right? What impact could FHIR have on the public health community going forward? Well, in addition to the birth defect reporting FHIR implementation guide that we're aiming to put together, I think we've mentioned that there's actually a project to create a birth and fetal death reporting FHIR implementation guide, and that it's going to have significant content overlap, right? Both birth reporting and birth defect reporting care about common pieces of information like the plurality of the pregnancy, about the pregnancy history of the mother, right? A whole bunch of different observations are of interest to both. And so we want to make sure that, when we set the rules of the road for EHRs to submit this data, that we're not asking them to send it one way to birth defect reporting and a different way to birth certification reporting, right? We want to harmonize our reporting requirements to make it easier for them to be able to reuse the code that they have to write. So that's sort of a very focused thing that could happen tomorrow. In a more general way, you're probably aware there's a whole lot of regulatory work going on. Recently, there have been final rules issued from the Office of the National Coordinator for Health IT and from CMS that support the 21st Century Cures Act. And both of these final rules call for increased use of FHIR APIs for the exchange of data and to allow patients to access their own data and share their own data as they move from one healthcare organization to another. And then there's another program out there called the Trusted Exchange Framework and Common Agreement, or TEFCA. This is more about being able to put a call out into the ether and say, I have patient John Smith in front of me now. I know he must have a history out there, but I don't know who it's with. So I'm going to put a call out there to this entire network of healthcare organizations saying, hey, if you know anything about John Smith, please tell me because I'm trying to treat this patient. Now, TEFCA right now doesn't call out the use of FHIR. TEFCA thought FHIR was a little bit immature at this stage, but it's fully expected, I think, that somewhere down the road that this TEFCA network of exchanges may someday use FHIR. So if you're at all up on TEFCA or interested, it may enter the FHIR realm going forward. So one of the problems that we have in public health and public health reporting in general, it's not specific to FHIR by any stretch of the imagination, is it's sometimes difficult to get vendors, be it EHR vendors or even the vendors of the systems we use in public health, to support these specifications. It's relatively easy to write a specification. It's much more difficult to convince people to actually use it, which is kind of surprising. But if you think about all the effort it goes into upgrading a system and then implementing it and changing your workflows, it's maybe not that much of a surprise that organizations are sometimes a little reluctant to implement this. And so we're always faced with how do we get people to buy in? And one of the ways that you do that is to make it easier for them. And one of the things that public health as a community led by the CDC has really been doing is trying to think of ways to make public health reporting easier. So it's easier to get the buy-ins from the Epics and the Cerners and the Allscripts of the world to be able to support these specifications that we put together. And one of the ways that you can do that, as you heard me say just a couple of minutes ago, is to make things as similar as possible, to harmonize the requirements so that when an Epic is reporting public health information, they don't have to, they can reuse the same infrastructure to send the patient record. They don't have to tweak it depending on who they're sending it to. And so one of the things that CDC is working on is a project they call MedMorph. It's a real fancy acronym that I never remember, but it's all about developing a single way of describing public health reporting and applying sort of a general pattern that can be reused regardless of whether you're reporting to an immunization registry, a disease surveillance system, or a birth defect system. Some of that infrastructure is common and reusable. Now, clearly, the content of what's being reported is very different. An immunization registry wants very different information than what your programs want. But if the architecture, the infrastructure is similar, that will help make it easier for vendors to implement FHIR reporting. And so at this point, MedMorph is still very much theoretical. It hasn't been implemented. It's not in a position to be implemented quite yet. But the electronic case reporting implementation guide that I mentioned earlier is piloting a very similar model. And so there's sort of our proof of concept that a common way of doing public health reporting is practical and in fact helpful, right? That it can actually smooth the implementation process. So that's all just a fancy way of saying we should all be working together to make sure that our asks as public health programs is as similar as possible. Okay, so what could a birth defect reporting implementation guide look like? Well, I kind of lied before when I said there wasn't one yet. There is a draft of one, and we'll provide you the link here. It's certainly not finalized and very much up for discussion, but if you're interested in just having a look at what it might look like, feel free to check that out. And basically what it is it consists of a set of narrative text, just describing the scope of birth defect reporting and the use cases that we have, a lot of the stuff that we've talked about sort of early on. And then it contains a set of these constrained resource profiles, resources to describe sort of the technical infrastructure of how you create a whole bundle of resources and move it around. It contains profiles on people, right? The subject of the report themselves, the mother and the father and the responsible person, things we've all talked about. A set of profiles on the clinical data about the birth defect itself and the procedures performed on the subject. And then the various observations, which is a lot of, in fact, what we've talked about, things about the pregnancy and the delivery and the prenatal care, right, that are important to the work that you do and how to send that data. And then, of course, you know, some of these things include specific codes, right? So for the sex of the subject, right, the subject can be male or female or undifferentiated or unknown, right? But probably not much beyond that. So we want to set some limits on some of the ways that you send some of this data. So coming very rapidly to the end here, just a few things to think about. Number one is, you know, we can write this specification, but again, if no vendors, no EHRs, none of the vendors that you purchase your systems from, if they don't support this, well, it's all for naught. And so we have to make sure that we're thinking about vendors and getting them on board and getting them excited about having this be a way of doing birth defect reporting. We have to be cognizant of what else already exists, right? And this goes back to that idea of harmonization and making things similar, right? We don't want to reinvent the wheel because it's then just another thing that these vendors have to actually do. There is a ton of information and thought that needs to go into security and privacy and authentication. You know, you think about your own programs, there's probably a limit on what some of the information you can access is, right? You don't need to know everything about the patient, just those things related to the birth defect and supporting the families of these subjects. And so it may not be appropriate for your programs to go in and access medication lists for the patients or for the mother. And so how do we write our implementation guide or implement these things to make sure that you're only accessing the data that you want to be accessing and should be accessing? And who should be able to access this data? Even with your own systems, you have different roles, different people doing different jobs, some of which probably have more data access than others. And how do we control that? And that's not all just FHIR interoperability specifications, but it's part of that bigger picture of how do we implement data exchange. We have to be cognizant that requirements and the triggering of events vary by location. I can say this is the bane of a lot of EHRs of, you know, what Tennessee requires is very different than what New York requires or Alaska requires, both in terms of what data they want and what they consider to be a birth defect. So we have to be a little bit open and a little bit flexible and allow jurisdictions to tweak things for their own uses. And then the last one just is terminology, right? That's that idea of, you know, for reporting the birth defect subject sex, is male, female, and unknown sufficient, right? Are there other concepts that should be in there? Can we agree on what that right set of genders is? Or do we have to allow, you know, some variability from one jurisdiction to another? So there's still a lot that goes into all of this. I will pause there with a whopping 2 minutes left and see if there's any questions that folks have. All right. I know that that's a ton of data. Do feel free to reach back out if you've got questions as some of it sinks in, or if you investigate some of these links and have questions. Don't hesitate to reach out with questions or clarifications you'd like.
Craig, this is Dickie. I was wondering if I could say something real quick.
Of course.
So first of all, I want to say thank you so much. You know, this was wonderful. I know that I at least learned a lot just from this presentation. And I know that there are a lot of folks from the National Defect Prevention Network on this call, but I was wondering if it would be okay if we share this presentation with other members of the network, or at least the Surveillance Guidelines and Standards Committee. Of course, you know, I won't do that without your permission, but would it be okay if we did share this with other members?
I would think so. Laura Rapley, I'm assuming this is based on previous things that we've put together, but I don't think there's any IP issues with sharing this presentation. Are you okay with that?
No, yeah, I'm okay with it.
Yeah, so share away.
Wonderful. Thank you so much.
Yeah, and this is Russ Kirby, and I also thought it was a great presentation. I learned quite a bit. So I feel like some of the things you went over I should have already known, but you made them much clearer the way that you presented. What I was wondering about is how can we connect a little bit more closely with the implementation guide that's being developed for birth certificates and fetal deaths, because that's obviously going to be something that's going to be integral to what we might do moving forward with developing one for birth defects.
Yeah, I think you're right. And so we've had discussions. The project for birth defect or birth and fetal death reporting is being led by the National Center for Health Statistics, the NCHS. We've been working with the sponsors of that project. Cindy Bush has been leading that. And we've been working with their technical folks, right, our equivalents on their side, to try and discuss, you know, what can be shared and how we share that. So we are working quite closely with them. I think if there's a larger need to get, you know, our community, the birth defect reporting community, at least, you know, engaging with them, we can try and organize, you know, a one-off meeting just to make sure that we're all on the same page. But we are working very closely with that team and with the CDC leadership running it.
Okay. Yeah, that's definitely interesting. I would be wondering whether NAPSIS might also be part of that.
I haven't heard them be involved, but it's something we can ask about.
It would certainly be smart on their part to be involved. But anyway, yeah.
Would it help if we presented this to NAPSIS and then asked for their participation?
Yeah, you know, I don't know quite what the relationship, how things are working internally between NCHS and NAPSIS, and they may actually have some of the leadership of NAPSIS as part of their group already. You know, it's very possible, you know, they do work hand in hand in terms of trying to meet standards for vital statistics reporting. So I just don't know.
Okay, well, we can circle back with NCHS that works with NAPSIS, Cindy Bush, as Craig mentioned, and ask them how much NAPSIS knows and if it would be helpful to provide this information to them.
Okay, we are actually a couple of minutes past the top of the hour, so just real briefly, next steps. We're going to take a brief hiatus. We are working away at taking all the information that you've given us and putting it into a domain analysis model in this FHIR IG. We will be reaching out to you later in the fall, probably September, October, and we will schedule a time to just give you an update on our progress. But again, in the meantime, if you've got any questions or concerns about anything we've talked about or FHIR in general or, you know, interoperability, please don't hesitate to reach out to us, and we will do our best to give you answers to your questions. So I think with that, unless there's any last minute questions, we will wrap up for the afternoon. All right. Thank you again. Like I say, we'll be reaching out in a couple of months. We did record this, so we will be trying to make that recording available to folks as well. So hopefully there will be a link to that coming out sometime next week, so that if you wanted to review this, or if there's any of your colleagues that couldn't make it today, it will be available for them as well. So we'll be reaching out to you shortly with that link, and then in the longer term for a follow-up meeting this fall. So thanks again for coming today and all your hard work over the last few months, and have yourself a great weekend.
Thank you, you too.